Elementary Stats, Unit 1, Lesson 4, Probability. Today we're going to be learning what probability is, and then we're going to find the probability of an event using the definition of what probability is. Before we can get into probability, we need to learn what an experiment is. So an experiment is an activity. We're going to perform the activity, record the results. Each time we perform the activity, it's called a trial. And for instance, flipping a coin would be the experiment. When you flip it, that's the trial, and it'll either land on heads or tails, that's the outcome, and the sample space is all the possible outcomes. You can see that flipping a coin has two possible outcomes, that was heads or tails. Rolling a number cube or a dice, the sample space is 1, 2, 3, 4, 5, 6. Guessing the number of marbles in a jar would be whole numbers. Those are all examples of experiments. By knowing what the sample space is, then we can figure out the probability of what each outcome is. So an event is the set of one or more outcomes, and the probability, which is written P and then parentheses the event, that's the probability of the event. For instance, the probability of flipping a coin and getting heads, it would be P parentheses head or P parentheses tail, and probabilities range between 0 to 100. If you flip a coin, the probability of getting heads, 50%. The probability of getting tails, 50%. The probability of the coin not ever landing is 0. It'll always land. So a probability of 0 means the event is impossible. A probability of 1 or 100% means it will happen. Your total probabilities always add up to 1 or 100%. So this chart gives you an idea of the probability that something will happen. Something that never happens has a probability of 0. Something that always happens has a probability of 100%. If it happens half the time, it's 50%. The closer it is to 1, the more likely it is to happen, and the closer it is to 0, the less likely it is to happen. So the probability here of winning a basketball game is 70%. Percents have to add up to 100, so that means if you have a 70% chance of winning, you have a 30% chance of losing. On the spinner, there are 1, 2, 3, 4, 5, 6, 7, 8 different regions. So the numbers are 1, 2, and 3. So your probability here is going to be a fraction. There are 1, 2, 3 ones, so that probability of 1 happening is 3 out of 8. You can make that divide that out and multiply by 100 to get a percent. There are 1, 2, 3 twos, so the probability of getting a 2 are 3 out of 8. And the last one, the probability of getting a 3 is 2. There are 2 out of 8, and we want to reduce that to 1/4. So you can leave them as fractions, or if you want to convert them to decimals or percents, you can do that too. The polo team has a 50% chance of winning, so that's easy enough. And what's the probability of the polo team losing? 50%. 50% chance of winning, 50% chance of losing. These percents have to add up to 100, and they do. A number cube or a dice has 6 sides, so each of these on a fair dice, each of these will have an equal probability, 1 out of 6. There are 6 possible outcomes, so 1 out of 6 for each of these. If you add up all of these, you're going to end up with 6 over 6, or 100%. So now this statement, to find the probability of an event, add the probabilities of all the outcomes included in the event. So an example of that would be if you flip a coin, your 2 possible outcomes are heads or tails. So heads had a 50% chance, tails had a 50% chance. So if I asked you what's the probability of getting heads or tails, you would add these up together to get the 100%. You flip a coin, you'll always get heads or tails on a standard coin. Probability can be given as a decimal, a fraction, or a percent. These probabilities are in decimals. If you multiply them all by 100, they would be converted to percents, but here you can leave them as decimals. So this problem says that the quiz contains 5 true or false questions, and suppose you randomly guess on every question. So if you guess on every question, your probability of getting none right is 0.031, which would be 3.1%. And this one would be 15.6%. This one would be 31.3, 31.3, 15.6, and back down to 3.1. But we can leave them as decimals. And it says, what is the probability of guessing 3 or more? So the probability of guessing 3 or more, you're going to add up 3, 4, and 5. So your probability of getting 3, 4, or 5 would be these numbers right here. And once you add them up, let me grab my calculator and math this out real quick. Looks like 0.5 or 50%. So I'm okay with this answer. Since they started in decimals, you can leave them in decimals. So the probability of getting 3 or more right is 50%. Same question, but this time they say, what's the probability of getting 2 or more correct? What is the probability of guessing 2 or more correct? So we already added up these three. It was 50%. So now we take the 50%, add it to this one right here, and we're going to get 81.813 or 81.3%. So the individual probability is less, but since you have multiple options, that's why the probability is higher. This one says, what is the probability of passing the quiz? And their definition of passing is getting 4 or 5 correct. So we're going to add up 4 and 5. So 0.187 or 18.7%. So the probability of guessing on a 5-question true or false quiz and getting a 4 or 5 is 18.7%. Looks like you're better off studying and not relying on probability to get an A or a B.